Okay, so in this video, we're going to take a look at a pandas notebook in Google Colab, and we're investigating the NYC flights, which is a package that comes with R for data science. Here we're going to make use of Python for data science, and that is based on chapter 5. And the outline of this chapter and the organization of this textbook, in fact, is the same as the R for Data Science textbook, which was originally developed by Garrett Grolemund and Hadley Wickham. So this textbook, Python for Data Science, Jay Hathaway and Katie Larson, follow fairly rigidly the outline chronology set out in the original R for Data Science textbook. And that's a powerful, useful, insightful approach to performing data transformation type exercises. And we'll set some of that out in this Google Colab, where we run side by side R and Python code. So to import in the various libraries, nycflights and tidyverse, we'll make initially use of R, and we'll run that in the Google Colab, and then we'll follow through by implementing a series of pandas commands, which again are based on this chapter 5 from Python for Data Science. Okay, so to activate R in Google Colab, we have to make use of the magic command, and thereafter, if we want to run an R command, or even here install our packages, we use this double percentage sign, which is a way then to run afterwards just code in a virtually or practically a native environment for R. Google Colabs typically run natively Python, but we can run R also just by making use of that combination of this command here, and then making use of this symbol. Okay, and we've loaded in the ggplots2 package, dplyr, stringer, forecats, tibble, tidyr, reader. We don't need all of that. And I'm also going to, but we will make a little bit of use of those commands available in tidyverse, and we're going to also install the package again, which is part of the R for Data Science text, which heavily makes use of the NYC flights, which is basically a fairly significant data set of flights data that's used in R for Data Science, the textbook. And we'll use here a few R commands just to bring up what's in the data set. So it's fairly significant, 336,776 rows by 19 columns. And we could use glimpse again to get another view slightly through a different prism. And again, we can see that the columns here, we have year, month, day, departure time, schedule, departure time, departure delay, arrival time, so on, all the way down time, hour. This is data that's collated by Department of Transportation for the 3 main airports in New York City, so LaGuardia, JFK, and Newark. They're the 3 main airports, so all the flights there are recorded. And I've went through a series of video clips outlining how we would set up querying, filtering, arranging, selecting data in R here in the Google sites, Vinegar Hill Data Labs. And we can see that the data set is coming from the Department of Transportation, and we have US airport codes and so on. So if you want to approach this data set and take a deeper dive and look at how we implement this type of querying, filtering, and so on. That's one portal of use, right, for that. Okay, so with glimpse, we can apply the str verb. We could just even in our do flights, and it'll bring up as again some of the overview, some of the key metrics associated, or a display of what the data looks like. Perhaps the best overview of the data is, in this instance, is to use the summary flights just to get a sense of maybe what type of data might be missing. So there are out of the 336,766 rows, each row denotes an individual flight. We do see that there's some missing values, 8,255 here for departure time, likewise for departure delay. A similar number here, arrival time, and so on. So there would appear to be some missing data. That could be in part flights that were cancelled, right? So that's perhaps one way of getting a sense of why the missing values. It may not entirely explain all the missing data, but it may be a factor, a contributory factor. Okay, so I want to use basically this package that I've and the data from the NYC flights package. I want to make it available in the Colab and save it out or write it out as a CSV to the content folder, CSV file to the content folder. We can see if we go in there and take a look, there's nothing in there except the sample data. So if we want to write out the flights data, as we observe here as a CSV file, then just simply use this command. Again, it's an R command, write.csv flights, and then the name of the file will appear as flights.csv. And if I close the content folder and open it up, we can see it appearing here. If we want to download, it's possible. If you want to delete, that's possible. If you close the Google Colab notebook, when you reopen on the next occasion, you've got to go through this process again of writing out. So even when you share the Colab here with colleagues, if you're working collaboratively with other individuals, when you share, they have to go through the steps here to get access to the data. Okay, now we're going to use some Python libraries. Specifically, we're going to make use of the pandas, and the idea would be we follow chapter 5 here of the Python for data science, which in turn is basically, it shadows very closely the chapter 5 of R for data science. Okay, so we've activated R, we've installed a few packages, and we've written out into the content folder the flights.csv. We import in then the pandas libraries with NumPy and Skippy. This library we possibly don't really need, but NumPy, pandas we will. You could have also obtained that data using a pip install for Python. I should have left a link to that. We'll take a look in a moment to see if we can find it. But a pip install for the NYC flights is also possible. Okay, so we want to read in from the content folder the flights.csv file, and then we run the flights.head, open, close brackets, and you can see the data that we have here is the same as the data we would have observed from the glimpse and str command. One artifact that emerges here is we get this 1, 2, 3, 4, 5. That wasn't in the original data set. We can get rid of it. It won't be a problem. We just need to drop the column unnamed colon 0. We'll see that in a moment. Just to see, we can use this command here just to observe how many variables are missing, how many values are missing in each column. So year, month, day are all complete. Departure time, 8,255. Departure delay, 8,255. Arrival time, 8,713. So we saw that from the summary statistics before when we looked at our arrival delay, 9,430. Missing tail num, 2,512. Okay, so we do have some missing data here. To get rid of this column, the unnamed column, very simply, we can run flights drop column, and then when we go to run again, head open close brackets, that column now has gone out. If you run it again, it'll create an error because it's looking for this column to remove, but we've already removed it, so we'll try and avoid running this command again. It comes up with an error. Again, if we want to look at the last set of values here, in this case, the last 5 values, just run tail. If we want to take a look at the last 10 values in the data set, so this is the December data from 2013, 10, we have 336,000, and it's month, I'm not sure why we're getting month 9 here at the end. So it should be November, December data. Month 9, month 1, 2013, 9. Okay, so it's a little bit unusual here, the organization of the data. It's giving us the tails, so these are the final values as month 9, that would be September, but there's definitely November, December data there. I just went and checked. So it's just how we arrange the data. We'll take a look at how we can order and arrange the data in a moment. I would have expected month 12 here and then the final day. It's just not initially being ordered by month and day here. So we'll check in a moment just to verify that we're getting December data. We can arrange the format of the time, hour. So that was the final column here as in the way that it's presented here. So basically we have year, month, day, and then hour, minute, seconds, right? So that's how the data is appearing. If we observe, if we just run flights, maybe in Python, run that, again, we can see the data follows that, the template as presented here. So year, month, day, hour, minutes, second. And then we can get the data types, the D types command. If we just take the data set, which we are referring to as flights, remember when we read in our data, we refer to it as being flights. So we PD read CSV flights, and that's reading this CSV file here. And we're creating an object called flights. Okay, so all our verbs and commands here are going to apply to the flights data set. The D type then is the data types, and we can see we have integers, floats, and objects. So if it's a name, it's coming up as an object. We can get the more information relating to the non-null. So we would appear to have the full amount of data in terms of years, always 2013. Month is the January to December, and then days. So all there are no non-nulls here. But then when we come down to schedule, sorry, the departure delay, you can see we're falling short a bit. So the full data set had the data frame had dimensions of 336,776 rows by 19 columns. And we can see here as we go down, some of the data is missing. Again, not that unusual. We can filter a row so that we can query. We could take a look at the data for the first day. So for instance, there are 842 rows because we have 0, 1, 2. So that gives us an extra 1, if you like. So there's 842 flights in day 1, so January 1, 2013, and these are the flights that would have taken place. We have, if you like, the departure time, the scheduled departure time, departure delay. So you can see there's a 2-minute delay here. Scheduled to leave at 5:15, left at 5:17. Arrival time 8:30. Arrived at 8:19. So arrival delay was 11. Was just a little bit behind time. And we can see the associations here. The carrier was United Airways. The flight 15, I think that's the flight number, tail number, Newark Airport, IAH, the codes. There are codes we can pull in from our data set. There is a brief summary here of the codes for each airport. So IAH is, let me just see, Atlanta, Los Angeles, O'Hare is ORD, Dallas Fort Worth, DFW, Denver, DEN, JFK, JFK, San Francisco, SFO, McCarran International Airport in Vegas is LAS, Seattle is SCA, Charlotte is CLT, Orlando MCO, Miami International Airport MIA. So some of them are intuitive. Phoenix is PHX, Newark is EWR, George Bush Intercontinental Airport is IAH, and I think that's Houston. Okay, so these are the 15 biggest airports with the most significant number of passengers. Okay, so we have, okay, so we've organized, sub-sampled our data just to pull out, to filter out those rows relating to the first day flight. So month 1, day 1, and that's fine. I mean, we could also just verify that we have a month 12. If we put in here month 12, day 1, it would appear here that we have December data relating to December, and and then the final 30 days past December. So if we have 30 days here, let's run that, and 31. Right, so the final day of the year, the 31st of December 2013, you can see all the entries are there. If we put in the 32nd day of December 2013, should come back with an error, right? So there is no day like that, but we're interested in the first day of the first month. And we have this double equal sign, meaning it's not that the values are equal to, it's that it's true that the month, it's true that the month is equal to the first month, January, and it's true that the day is equal to the first day of the month. Okay, we could create an object, January 1, and that could be saved as, so for instance, if we just follow up then and have January 1 and run that, we would get data relating to the first day. Now, not every instance is reported out here, but that could be saved as an object and downloaded or saved out to the content folder. Okay. If we want to take a look at the November and December of 2013, we can use this flights query command, and we have 55,403 flights. Again, if we want to create an object and give it the object a name, so November, December, and then print that out, we can do it by here using a single equal sign, and that has the effect of creating an object then that we can work through. Okay, so in this next section here, we're going to consider how to pull out of our data set where flights were delayed either at departure or arrival. And we can set out this flights.query command, which basically allows us to draw out of our data set those entries that correspond to satisfying either this condition or this condition here. So arrival delay in excess of 120 minutes or 2 hours, or satisfy the departure delay in excess of 120 minutes. Now, when we look down into our data set here, or what's reported out, we might note that the departure delay was just 101 minutes, which is obviously less than 120. But when we look at the arrival delay, it's in excess of 120 minutes, arrival delay in excess of 120 minutes, 137 here. So you can see we satisfy this condition. So that's why this flight on the 1st of January 2013, flight 119, or the entry for 119, satisfies the arrival delay condition. That's why it's incorporated in. Okay, if we want to, and again, it's probably worth noting that the data sets that we have here is the nycflights13 data set, and the code we're using is coming from Python for data science, and this is chapter 5, and we're really trying to compare how we would use the dplyr function and the pandas functions, how they correspond to each other. So the filter, verb, arrange, verb, select, verb, rename, mutate, group by, summarize, have analogs in the pandas library. So if you're familiar with these or worked through already the dplyr verbs and have some understanding of what these particular verbs do, then you have quite a strong intuition or insight into how the pandas commands here operate. Okay, so if we go to the next command, flights query arrival delay less than or equal to 120, or departure delay less than or equal to 120. If we just look at the first entry here, we can see we satisfy the departure delay less than 120. Departure delay less than 120 minutes, less than or equal to 120 minutes. And then over here, arrival delay less than 120 or equal to or less than 120 minutes. Again, if we go down through our data set, we can see each of these seem to be satisfied, right? And likewise here, so there's no exceptions. Okay, arrange then, we observed before that when we looked at the arrange dplyr verb, the flight sort values by year, month, and day provide us with some correspondence for the arrange verb in R. Let's just run and see what happens. Basically, we're filtering out the variable, the data arranged in order of the year, month, and day. So, and all the way through. And at the end here, we have the final 2013, 12, 31. So the order of the entries are based on the flight sort values. Now, we could apply another criterion there, maybe to get a slightly altered chronology, but the flight sort values gives us the equivalent of what a range would do in the R dplyr command set. Okay, if we flight sort values by year, month, day, and say ascending is equal to false, we get the descending, and then the order of the variable changes. So the last entries would be the 2013, month 12, day 31, the 31st of December 2013. But then the first entry is the 1st of the 1st, 2013. So we've rearranged the order of our variables here in the process, and there are 336,776 rows in our data set. If we just wanted to get the data relating to year, month, and day, we could use flightsfilter, right? And that would be convenient for selecting the columns, if you like. So in the dplyr or verbs, we use select to pull out specific columns. Here we can use filter, the filter command, to produce the same output. And we could do flights and drop columns year and day. That would remove year and day, but leave month and everything else in the data set. We could also, using the LOC command, flights.loc, and then just the columns relating to year, month, day would appear, right? And again, we have the equivalents using the select command in the dplyr or, and flights lock and just year today would allow us to bring up year, month, day. So everything between year and day, that would include in this instance month, we can introduce then here in the Colab. Rename can be important sometimes because a sales rep might change, or you're trying to streamline a particular name that corresponds with maybe there's two versions of the same name and you want to unify whatever. So rename may be a significant way. Here we're just changing from lowercase to uppercase year and month, and we can rename flights, rename columns allows us to do that. And again, that's a useful command to have available when manipulating and transforming your data. Also, we can keep the labels from the axis from which research, so we can match the column name that begins with CH. So if we required to just select those columns that had schedule or SCH in their label, we can do that using flightsfilter's regex, and then we have SCH. And again, that corresponds to the scheduled departure time and scheduled arrival time. Okay, so starting with SCH, we can use this command to select out those columns. Likewise, flightsfilter, again, we're selecting columns here, and it is times, and so it is time, should I say, and again, it's departure time. So departure time, again, ending with time. We have 1, 2, 3, 4, 5 columns that end in time, and we can pull that out using this command. And also, again, we can select those columns relating to where we have underscore departure underscore. And again, we don't have schedule time, but if we have a sense of perhaps an individual's name or information relating to a particular column, but we don't have the full information, but we do recall somewhere in the label this appeared, we can quickly expedite the subsampling or subsetting of that column out. We can find or discover that column, and that could be very useful where we have dozens or maybe several hundred columns in our data set. If you want to add a new variable, again, if you go back to before we had mutate for R, which allows us to produce new columns based perhaps on a formula, we can use the assign command in pandas. And in this instance here, we're hoping to select from our flights data to produce, if you like, a smaller, more compact data set where we have information relating to year, month, day, delay, distance, and airtime. Now again, if we take a quick look here, year corresponds to year, month to month, day to day, then delay. So those columns that incorporate in delay, and we have two here, the departure delay, arrival delay, the airtime, distance, and then we generate using the assign command to new columns relating to gain and speed. And if we take a slightly more forensic view here, we can see that when we subtract departure delay, so we subtract arrival delay from the departure delay, we're getting that 9 minutes. So in other words, the flight left 2 minutes delay, arrived with 11 minutes delay. That meant we have a -9 gain, or we lost 9 minutes in the air. Again, if we take the next one, left with a delay, or departure delay was 4 minutes, arrived with a 20-minute delay, that was 16 minutes lost in the air. However, in this instance below entry 3, we have a flight departure delay of 1 minute, and we have airtime arrival delay of 18, and that produced a gain, an actual gain. So you arrived early 18 minutes, so you made up 17 minutes in the air. Okay, and that's producing that output. Now, in the data set that we have here, it's just the first 5 entries. If we wanted to explore that a little bit further, we could maybe go 20 entries, the first 20, and so on. Okay, so that's a useful way of generating new columns based on existing columns, and again, selecting those columns that are of relevance for that particular query. Okay, we might also want to generate additional computations here. So again, we're producing the same small flights data set, but we're also incorporating in departure delay, arrival delay, taking the difference, so that produced the gain. And then the hours, we take the minutes and divide by 60, that produces hours, and then we do a speed as a gain per hour estimation. And again, we can, if we want to take a look at the first 10 entries, head 10 and so on, right, to produce out whatever is required. Also, sometimes important here, we might want to split this 517 between hours and minutes. That could be important because 60 minutes in an hour. So it may be relevant that we can filter out or splice out the hours from the minutes. And this command here, flightsfilter, take the departure time column, assign, then create, like mutate before, hour, produce by taking the remainder here of, we divide the 517 by 100, that gives us the 5. And then the rest is the remainder, which is the 17. And that's how we produce the 5 and the 5 hours and 17 minutes. Okay, and again, we're making reference here to assign in our estimation, right? Pandas estimation. Okay, and then finally, we're going to group summaries or aggregate. So for instance, if we want to take the departure delay and for the entire column, estimate the average delay for all the flights, 336,776, this flights.ag, our data set, and then we're aggregating and we're pulling out from that aggregation the average. So using the NumPy suite operator, we estimate the mean. So using NumPy in conjunction with the pandas produces this mean delay for the entire year for all the flights of 12 minutes and 0.63 of an hour. So again, we're not using 60 minutes. That this is not 12 minutes 60 seconds. Of course, this is 12 minutes 12.63907 minutes. Okay, that might be worth noting. And again, group by allows us then to estimate, if you like, a sort of pivot table here where we can group the data by year, month, day. So that produces this combination. So in our data sets that we're subsampling out, we're observing each flight by each day in terms of the day, month, and year. And then we're estimating the delay here for each day by day, and then we're producing an average delay for each day. So the first of the first 2013, the second of the first 2013, and all the way through for the 365 days in that year. And then we can produce by destination flights, and we can group by destination, and then aggregate, create the data set. So if we run this estimate and create a data set, so we first of all by day and by day aggregated and got a daily average delay, and then by destination, and then we group our data set by destination, and then we estimate, we count, C-O-U-N-T, we count the, so we refer to the distance and the size. The distance is estimated to be the average. So when leaving LaGuardia, Newark, and JFK, we're taking the average to the destination. So the distance will be different depending on where in New York you're flying out from, but we take the average. So we get the distance here is the average distance from the 3 airports to a given destination. We're counting the number of flights to that destination, and then we're estimating the delay as the average delay. And so, for instance, Atlanta, which is fairly significant, there was 17,215 flights to Atlanta in 2013. The average distance was 757 miles, and the average delay was 11 minutes and 11.3 minutes. Okay, we could sort by delay, so we could create, if you like, those on average where we had the greatest delay. So, for instance, CAE, I'm not familiar with that code, but it's a fairly significant airport. It's 116 flights. TUL is probably Tulsa. There's 315. The average delay to Tulsa was 33 minutes. That's a distance of 1,215 miles on average between the 3 airports and Tulsa. The average delay was 33. So again, given the significant numbers involved here, on average, fairly significant delays for, I think it's Tulsa, 30 minutes, then 28, and then LAX, where there's only one flight to had people arrived 22 minutes early. So this one is definitely an outlier, and because it's just one flight, probably not that significant. And SNA was 7 minutes early. So these flights would appear to have been well on time, but then the ones with the biggest delays are those airports that have this code. And again, just to remind you, the code that you might take a look at. So for the 15 most significant airports, largest airports by passenger numbers in the US would be Atlanta, LAX is Los Angeles, ORD is O'Hare, Dallas, Fort Worth, DFW, and so on. And we can actually bring up in our data set here, we do have in the NYC flights, we do have the code. We'll just bring that up. And again, if we wanted to take a look at the code for the airports, we could just go into the go back to the original NYC flights data set, and then just include in, I think it's airports, and run that command, and that would bring us up the list. So for instance, we could do it this way. We could create an object in OR. So let's say airports data, and then create an object, and then we could write that out. So we could go back to our command we had before for writing out the airports. You might recall we used write.csv, and then we used the file and then the name we wanted to create, which then we could post into the content folder. So for instance, here we used this command, write.csv flights. So let's just take that as our template, copy, selection, bring it down here. and create a new cell, Control V. Now it's no longer flights, it is airports data. Airports data. And the name we'll apply here is just airports data. Let's execute that command. That will produce here in the content folder a file called airports data. We can download that file. It won't be, well, it'll be significant enough file, but not so big. And we can take a look then at the flights here, the airports here, and we can look at the different codes. So the name of the airport and the code. And for instance, if we're looking for Atlanta, find, let's go into home and find and Atlanta. Okay, Hartfield, Jackson, Atlanta, and the code is LTL. And for instance, if we want to find the code here for just confirm that TUL is Tulsa, let's go back in, TUL, and okay, it's Tulip. Let's see, is there another one? Tulsa, TUL is Tulsa International Airport. Okay, so that's a summary then of the R and Python commands, or R, dplyr and panda commands that can be used to interrogate this nycflights13 dataset.